graphing a line using the slope-intercept equation. And more specifically, it should be the slope-y-intercept equation. Now this is just a linear equation written in a form that's going to help us graph it. It's the same linear equations we've been dealing with. It's just written in a form that's helpful for graphing. So m represents what the slope can be. It's a variable that's representing our slope. And the b represents the y-coordinate of the y-intercept. By looking at this, we can actually graph our equations quite easily. Let's first look at cases where b is equal to 0. The y-intercept is where the line crosses the y-axis. It's the point on the y-axis that that line crosses. And so when we look at where b is equal to 0, it's going to cross the y-axis and the x-axis in this case at 0. So this equation right here, y equals 5x, has our y-intercept at 0. It only has our slope. Now our slope is the change in y over the change in x. So when we look at this, we know it's going to cross our graph at 0 right here, at 0, 0, and our slope is 5. That means we go up 5 on the y-axis every time we go over 1 on the x-axis. So if we start at 0, up 5 over 1, up 5 over 1, we can plot those 2 points. We can connect them with a straight edge into a straight line. And I have my slope of y equals 5x. Here's another example, y equals 1/3 x. In this case, my slope is 1/3. My y-intercept again is at 0, and so I'm going to start here at 0. Now my change in y over my change in x, my change in y is 1, my change in x is 3. So each time I go up 1, I go over 3 on the x-axis. So I can start here, up 1 over 3, plot a point, up 1 over 3, and that's also on the line. I could keep doing that all the way there, but that is my line. Let's look at one that has a negative slope. Here I have y equals negative 2x. My y-intercept is 0, so I have it at 0, and this time my slope is negative. So my slope is negative 2. So I'm going to go down 2 every 1. So I go down 2 over 1, down 2 over 1, and I can graph that line. Let's take a look at an example where we have a different y-intercept and we have the same slope. So I have two equations here, y equals 3x plus 2 and y equals 3x minus 5. They're written in my form y equals mx plus b, and so I can use that form to help me graph them. Well, let's look at really what that y-intercept means. So the y-intercept is where it's going to cross the y-axis, my y-axis right here. That happens when I'm not going either way on the x-axis. I'm not going this way or this way. I'm right at x equals 0. So if I can set x equal to 0, I can find the y-coordinate of my y-intercept. So over here I've substituted in for x as 0, and I have y equals 3 times 0 plus 2 to figure out what y is going to be equal to. So when I do 3 times 0, I get 0 plus 2, and y equals 2 when x equals 0. So my y-intercept is at the coordinate point 0, 2. This 2 represents the y-coordinate of my y-intercept, where it's crossing the y-axis. Now in order to graph that, I'm going to start at my y-intercept. I'm going to start right here at the point 0, 2, and I'm going to use my slope. My slope, remember, is going to be the change in y over the change in x, and so my slope for this equation is 3 over 1. That's the same thing as 3. So I'm going to go up 3, change in y, up 3 over 1. So every time I go up 3, I'm going to go over 1. I can plot that point. Up 3, over 1, plot that point, use a straight edge to connect, and I have graphed my line. I can do the same thing with this equation. So I have y equals 3x minus 5. Notice the negative 5 here, changing from that too. My y-coordinate of my y-intercept is going to be negative 5. Again, I'm showing you how that intercept comes from this equation. Plugged in 0 for x because we're not going either way on our x. And we have 3 times 0 minus 5. y is equal to -5 when x equals 0. So my y-intercept for this equation is at 0, -5. That -5 represents the y-coordinate of my point. So I can go ahead and plot that down here at 0, -5, and then I'm going to use my slope, the change in y over the change in x. And I'm going to go up 3 on my y and over 1 on my x and plot that point. Then I go up 3 and over 1 and plot that point, and I can go ahead and connect the dots and graph those lines. Let's look at another example. We have y equals 2x plus 1. My slope is 2. The y-coordinate of my y-intercept is 1. So I'm going to start at the point 0, 1, right here. Then I'm going to use my slope. My slope is 2, which is the same thing as 2 over 1. That's the change in y over the change in x. I'm going to go up 2 for every 1 I go on the x. So up 2 over 1, up 2 over 1. Plot those points and connect them with a straight edge. Now what if we have a negative slope? So we have y equals -4x plus 3. My slope is -4. My y-coordinate of my y-intercept is 3. So b is equal to 3 in this case. And that's where we're going to begin. We're going to begin at 0, 3 right here. And then we are going to use our slope to find the next point. Our slope is the same as -4 over 1. That means I'm going to go down, because of the negative, on the y-axis 4 for every 1 I go over on the x-axis. So I go down 4, 1, 2, 3, 4, over 1. I can plot that point. Down 4, over 1. Plot that point, use a straight edge to connect. Now what if my slope is a fraction? Y equals -2/3 plus 2. So if I'm looking at my y-intercept form here, or my slope-intercept form here, I have y equals mx plus b. My slope is -2/3. My y-intercept, my y-coordinate of my y-intercept is 2. So that's where I'm going to begin, is at 0, 2. Then I'm going to use my slope. Change in y over change in x. Change in y is -2. Change in x is 3. So I'm going to start right here at the point 0, 2. I'm going to go down 2. 1, 2. And I'm going to go to the right 3. So I'm going to go on the x-axis 3. 1, 2, 3. Plot that point. Down 2, over 3. Plot that point and connect all of the dots. Now what if my equation doesn't look like it's in y-intercept form? Now it's just like that friend of yours that has the big long name that they call him Bob. So if his name is really Robert and you call him Bob, that's what you know him by. So this is just another form of that equation. You have to manipulate it around so that it looks like what you want. Take off all of the costume. So in order to do that, we're going to solve for y. So to solve for y, we want y by itself. So I have 2y plus x is equal to 6. I'm going to subtract an x from both sides so I can get that y by itself. And I have 2y is equal to -x plus 6. So I could have said 6 minus x, but that's not looking like my form. My x comes before my y-intercept. So instead of 6 minus x, I put the equivalent form of -x plus 6. It's the same thing. Divide both sides by 2. So I'm going to divide my y by 2, and I just have a y, and that's equal to -x over 2 plus 6 divided by 2, which is 3. So now it looks a lot like my slope-intercept form, and I can use that. I can rewrite this as y equals -1/2 x. This -x right here is really just a -1x. So -1/2 x plus 3. Now I have my slope and I have my y-intercept, and it looks exactly like the Bob I know, and so we can graph this equation. We're going to start at the y-intercept, which is 0, 3, right up here, and then we're going to use our slope, our change in y over change in x, so I'm going to be going down y because of the negative, going down 1y, and I'm going to be going over 2 on my x-axis. So down 1, over 2, plot that point. Down 1, over 2, plot that point. I could keep going, down 1, over 2, plot that point, and then I connect them into a straight line. These are the solutions for this equation.